वेलकम टू आवर चैनल। आज की सेशन में हम न्यूटन्स लॉज ऑफ मोशन स्टार्ट करेंगे। ओके, न्यूटन्स लॉज ऑफ मोशन। इस चैप्टर में पहले हम फोर्स क्या होता है देखेंगे। फोर्स इज ए पुल और पुश। इट इज ए पुल or push. When you pull, you exert a force. When you pull, you exert a force. Okay. Towards yourself. Towards yourself. When you push, you exert a force away from yourself. When you push, you exert a force away from yourself. Force is an interaction between two objects or between an object and its environment. Let it be a body. When you pull this one, applying force F, it is called pull. इसको pull कहता है। ये यहाँ पे एक बड़ी है, इसको पीछे से धक्का मारते हैं तो इसको push कहते हैं। So force is an interaction between two objects. Force is an interaction between two objects or between an object or between an object and its environment. When a force involves direct contact between two objects like push or pull, known as contact force. Known as contact force. Normal contact force. Normal contact force. Whenever a body is in contact with a surface, the surface exerts a normal force over it. Whenever a body is in contact with whenever a body is in contact with a surface, the surface exerts a normal force over it. That means towards the body. Okay. So whenever a body is in contact with a surface, the surface exert a normal force over it. So the normal, this body is kept on the surface, horizontal surface, and here it is a opaque oval surface. This is the normal. If body is kept like this, then this is the normal. If the body is kept like this, then this is the normal. So whenever a body is in contact with the surface exerts a normal force over it. When a body losses contact with the surface, the normal force vanishes. In that case n equal to 0. इसमें क्या होता है n 0 हो जाता है. Then friction. फ्रिक्शन क्या है, चलो देखते हैं. The friction force exerted on a body by a surface act parallel to the surface. The friction force exerted on a body by a surface acts parallel to the surface. This is normal. This is motion. This is F is friction. Okay, this is a rough surface. So the frictional force exerted on a body by a surface act parallel to the surface. Tension. The force exerted by a straight string on an object to which it is attached is known as tension. The force exerted by the straight string on an object to which it is attached is known as tension. To which it is attached is known as tension. Okay. So now this is surface, this is the body, this is tension. The body is hanged like this, so this is tension. This is also tension. Okay. The force exerted by a straight string on an object to which it is attached is known as tension. Number one, if string is if string is light or massless, tension in the string at every point is same. Number 2, if string is having mass, the tension in the string at every point is different. The pool of, if string is light or massless, tension in the string at every point is same. If string is having mass, then the tension in the string at every point is different. So W is the pool of the gravity. The force is a vector quantity. Okay, the force is a vector quantity. The force completely defined by its magnitude and direction. Direction means the direction in which it acts, and number 3 point, it is a point of application. ये सब डिपेंड करता है. सो फोर्स का यूनिट क्या होता है? न्यूटन होता है. द फोर्स इज ए वेक्टर क्वांटिटी. ओके, द फोर्स is completely defined by its number 1 magnitude, number 2 the direction in which it acts, and number 3 its point of application. The SI unit of force is Newton. Okay, if more than one force act on the object, we can find the resultant by the vector addition. मतलब वेक्टर एडिशन प्रिंसिपल के हिसाब से अगर एक से ज़्यादा फोर्स एक्टिंग करता है तो हमको इसका रिजल्टेंट निकालते हैं. ओके, सो इफ मोर देन one forces act on an object, we can find the resultant force by vector addition. Newton's first law. If the net force acting on a body is 0, it continues in its state of rest or in uniform motion in a straight line. If, चलो देखते हैं क्या होता है न्यूटन फर्स्ट लॉ. इफ द नेट फोर्स acting on a body is 0, it continues in its state of rest or in uniform motion in a straight line if summation of f net equal 0, then a bar equal to 0. If the net force acting on a body is 0, it continues in its state of rest or in uniform motion in a straight line. That is, summation of net force is equal to 0. Then a bar equal to 0. Okay. So means acceleration is also 0. Here we are assuming the body as a point of mass. When a body is at rest or moving with a constant velocity, we say that the body is in equilibrium. एक body when a body is at rest or moving with constant velocity, we say that the body is in equilibrium. Summation of bar equal to 0, body in equilibrium. Here you are assuming the body as a point of mass. Here we are assuming the body has a point mass. The tendency of a body to remain at rest or keep moving once. The tendency of a body to remain at rest or keep moving once it is set in motion results from a property known as inertia. If a body is having larger mass, it has larger inertia. Newton's first law is known as laws of inertia. Okay. If a body has larger mass, then it has larger inertia. Newton's first law is known as laws of inertia. Laws of inertia. Whether a body is at rest or in uniform motion or accelerated, it depends on the frame of reference. Okay? Whether a body is at rest or in uniform motion or accelerated, it depends on the frame of reference. The acceleration of a body is in general different when measured from different frames or reference. Okay. So Newton's first law of motion is valid only in the inertial frame of reference. Okay. So the inertial, the acceleration of a body is in general different when measured from different frames of reference. Different frames of reference. The earth is the least approximately at the inertial frame of reference. Strictly speaking, the earth is not a completely inertial frame of reference due to the acceleration associated with its rotation and its revolution around the sun. Though the effects are small, we will always work from the inertial frame of reference unless stated. All frames moving uniformly with respect to an inertial frame are themselves inertial. Okay. So Newton's law is valid. Newton's law is valid only in the inertial frame of reference. The earth is at least approximately an inertial frame of reference. The earth is approximately an inertial frame of reference. Okay. Strictly speaking, the earth is not a completely inertial frame of reference, but due to the acceleration associated with its rotation and revolution around the sun, though these effects are small. ये if इसका effect small होता है कि इसका रोटेशन और जो रिवोल्यूशन होता है ना, रोटेशन अराउंड इसका ओन एक्सिस में रोटेशन होता है, रिवोल्यूशन सन की तरह अराउंड होता है, तो इसका इफेक्ट बहुत स्मॉल होता है. So we will always work from the inertial frame of reference unless stated. Okay. अगर कुछ नहीं दिया है तो we have to work from the inertial frame of reference. Then our Newton's second law. न्यूटन सेकेंड लॉ। सेकेंड लॉ क्या होता है, चलो देखते हैं। इफ ए नेट एक्सटर्नल फोर्स एक्ट्स ऑन ए बॉडी, द बॉडी एक्सीलरेट्स इन द डायरेक्शन ऑफ द नेट फोर्स। द नेट फोर्स इज इक्वल टू द मास ऑफ द बॉडी मल्टीप्लाइड इट्स एक्सीलरेशन। मतलब समेशन ऑफ फोर्स मास इनटू एक्सीलरेशन होता है। हाँ, इफ ए नेट एक्सटर्नल फोर्स एक्ट ऑन द बॉडी, the body accelerates in the direction of the net force. The net force is equal to mass of the body multiplied its acceleration. So force is equal to mass into F is equal to ma. The above formula is valid when mass m is constant. Newton's second law is valid only if the internal frames valid only in the inertial frames of reference. Newton's first law is a special case of second law when a equal to 0. Okay. If a net external force acts on a body, the body accelerates in the direction of the net force. The net force is equal to the mass of the body multiplied by its acceleration. So summation of m into a. The above formula is valid when a mass m is constant. Okay. So Newton's second law is valid only in the inertial frame of reference. Newton's first law is a special case of second law when a equal to 0. Okay. So the above formula is valid when a mass m is constant. The second law is valid only in the inertial frames of reference. Newton's first law is a special case of second law when a bar equals 0. Newton's third law. If a body A exert a force on another body B, then B exert a force minus force on A reaction. The two forces act on different bodies. Action and reaction are simultaneously, either force can be called as action or reaction. Okay. So every action has equal and opposite reaction. Every action has equal and opposite reaction. If a body A exert a force F on another body B, an action, then B exert a force minus force on a reaction. Force on A is the reaction. These two forces act on different bodies. These two forces act on different bodies. Action and reaction act simultaneously. Either force can be called as action or reaction. Action and reaction act simultaneously. Either force can be called action or reaction. Let us consider an example to explain action reaction. चलो देखते हैं. Let us consider an example to explain the action reaction. A man drags a block across a floor by pulling on a rope. Okay, attached to the block. So this is a block connected with a rope. Okay, and force is applied here. Then the block a bear FRB a bear is FRB is a rope FRM, FMR, so man, M for man, R for rope, B for block. Okay, so FBR मतलब force on the block due to the rope, force on the block ड्यू टू द रोप. ठीक है. FRB इसका उल्टा होगा, फोर्स ऑन द रोप ड्यू टू द ब्लॉक. ठीक है. FRB फोर्स ऑन द रोप ड्यू टू द ब्लॉक. FRM फोर्स ऑन द रोप ड्यू टू द मैन. ठीक है. FRM force on the rope due to the man. FMR force on the man due to the rope. ठीक है. Working with Newton's first and second law. How to work that we will discuss. अभी हमको देखना है कि न्यूटन का फर्स्ट और सेकंड लॉ कैसे काम करता है. ठीक है. Newton's law is applicable for points of masses and relative to the forces acting on the particle with its acceleration and its mass. अभी हमने डिस्कशन किया है कि न्यूटन्स लॉ कहाँ पे एप्लीकेबल हो सकता है. मासेस, point of masses relate to the force acting on the particle with acceleration and mass. Okay. So working with Newton's first and second law. Newton's law are applicable to for points of masses. Newton's law are applicable for point masses and relate to the force acting on the particle with its acceleration and its mass. Step 1. Decide the system. The system may be a single particle or an object or a combination of blocks or two blocks attached to the string or a piece of rope, etc. Okay. So पहले हमको डिसाइड करना पड़ेगा सिस्टम कैसा है. ये सिस्टम, the system may be a single particle an object a combination of blocks two blocks attached to string, a piece of rope, etc. Okay, a piece of rope, etc. It is essential that all parts of the system should have identical acceleration. इसका मतलब it is essential that all parts of the system should have identical acceleration. Okay, step 2. After deciding the system, identify the forces acting on the system due to all the objects other than the system. सिस्टम डिसाइड करने के बाद हमको फोर्स को आइडेंटिफाई करना पड़ेगा जो सिस्टम के ऊपर काम करता है ड्यू टू all other objects of the system. Okay, after deciding the system, identify the forces acting on the system due to all the objects other than the system. Step 3. Make a free body diagram. Make the body free of its surrounding and sketch forces acting on the body with the help of arrows showing the magnitude and direction of the force. इसके लिए स्टेप 3 में हमको एक फ्री बॉडी डायग्राम ड्रॉ करना पड़ेगा जिसमें हमको दिखाना पड़ेगा फोर्स आरो मार्क के हिसाब से. ठीक है, अब क्या लिखेंगे? मार्क मेक ए फ्री बॉडी डायग्राम make the body free of its surroundings and sketch forces acting on the body with the help of arrows showing the magnitude and direction of force. That is a block placed on the table. A block placed on a table. Okay, ये एक टेबल है. इसका पर ब्लॉक m रखा हुआ है, m n w mg free body diagram of a block. A ball attached to a string tension T, mass m, tension T, W, weight of the body, mass into gram, mg, a BD of a ball. Okay. Number 3, inclined plane, let this angle theta, mass m connected to the support. Okay. The mass m, tension T, Newton, W equal to mg, a BD of a block. Step 4, ठीक है, resolve the forces in mutually perpendicular direction and apply the formula. formula क्या है? Net force is equal to mass into acceleration होगा for each direction. If the body is in equilibrium, net force 0 होगा. ठीक है, तो resolve the forces in mutually perpendicular direction. Resolve the forces in mutually perpendicular direction and apply net force is equal to mass into acceleration for each direction if the body is in equilibrium net force equal to 0. The procedure will be clear after solving the problems. जितना प्रोसीजर अभी बताया स्टेप 1, 2, 3 और 4 में ये सब क्लियर हो जाएगा और सम एडिशनल पॉइंट अभी डिस्कशन करेंगे. ओके. If the blocks travel equal distance in equal time, then acceleration is same. ठीक है? If the blocks travel equal distance in equal time, their acceleration is same. If the blocks travel different distances in equal time, the blocks travel different distances in equal time, the accelerations are proportional to the distances traveled or relation between accelerations can be decided by kinematic condition. Okay, number 3, if a string is light, अगर ये string light होता है तो tension each point on the string is same. If a string is light तो क्या होगा? The tension at each point of the string is same. If the string is having mass, the tension of each point of the string is different. If the string is having mass, the tension at each point of string is different. Number 4, a pulley is a device which changes the direction of the force. A pulley is a device which changes the direction of force. Normally, if you assume pulley as massless or light, or light and frictionless. And frictionless. The tension in the string on either side is same. ठीक है, ये पुल्ली है. Okay. Now, non-inertial frame of reference. Non-inertial frame of a frame of reference having an acceleration with respect to an inertial frame of reference is called a non-inertial frame of reference. Okay. A frame of reference having an acceleration with respect to an inertial frame of reference is called non-inertial frame of reference. Newton's laws of motion 1 and 2 are not applicable in the non-inertial frame of reference. A frame of reference having an acceleration with respect to an inertial frame of reference is called non-inertial frame of reference. Newton's law 1 and 2 are not applicable in the non-inertial frame of reference. We can use Newton's second law, that is net force is equal to mass into acceleration in a non-inertial frame of reference, provided we apply an imaginary force, pseudo force minus ma0 on the particle, where a0 is the acceleration of non-inertial frame with respect to an inertial frame of reference. हम न्यूटन्स को सेकेंड लॉ को यूज कर सकते हैं जहाँ फोर्स मास इंटू एक्सीलरेशन होता है इन ए नॉन इनर्शियल फ्रेम ऑफ रेफरेंस प्रोवाइडेड इसका इमेजिनरी फोर्स, हमको इमेजिनरी फोर्स लेना पड़ेगा माइनस ma0 करके ऑन द पार्टिकल, where a0 is the acceleration of a non-inertial frame with respect to an inertial frame of reference. So we can use Newton's second law. Net force is equal to mass into acceleration in a non-inertial frame of reference provided we apply an imaginary force that is pseudo force on the particle where A0 the acceleration of a non-inertial frame with respect to an inertial frame of reference. Okay. A block of mass 5 kg reacted upon two perpendicular force 7 Newton and 24 Newton. Find the magnitude and the direction of acceleration of the block. Solution. Resultant force क्या होगा? F is equal to root over of 7 square plus 25 whole square. So this is coming up 25 Newton. According to Newton's laws of motion, acceleration of the block A is equal to F by M. So 25 by 5 meter per second square. The acceleration is in the direction of the net force. if alpha is the angle made by the net force F with the direction of force 24 Newton, then tan alpha equal to 7 by 24 or alpha is equal to tan inverse 7 by 24. Okay, so this is answer. Tan inverse 7 by 24 is what? It is coming up 7 divided by 24, 16.26. Okay. Next. Example, the three forces F1 vector is equal to 3i plus 2j minus k, F2 vector 4i minus j minus 2k, and F3 vector 23j plus 3k Newton act on the block of mass 5 kg. Calculate the acceleration of the particle. Okay. Three forces. F1 vector is equal to 3i cap plus 2j cap minus k cap. F2 vector is equal to 4i cap minus j cap minus 2k cap, and F3 vector is equal to 23j cap plus 3k cap Newton act on a block of mass 5 kg. Calculate the acceleration of the particle. ओके, चलो देखते हैं इसका सॉल्यूशन कैसा होता है. पहले हमको नेट फोर्स निकालना पड़ेगा. ठीक है, तो ए वेक्टर इज इक्वल टू F1 वेक्टर प्लस F2 वेक्टर प्लस F3 वेक्टर. सो 3i कैप 2j कैप माइनस k कैप प्लस 4i कैप माइनस j कैप प्लस 23j cap 3k cap. So this is coming up 7i cap plus 24j cap. So a vector is equal to f, that is equal to root over of 7 square plus 25 square. So 25 न्यूटन आता है. तो एक्सीलरेशन क्या होगा? Acceleration of the block F by m, so 25 by m 5 मीटर पर सेकंड होता है. So this is answer. Example 3. A constant force acting on a block of mass 5 kg changes number 1 its speed from 6 meters per second to 10 meters per second in traveling a distance 8 meters in a straight line. B. Its speed from 2 meters per second to 8 meters per second in 3 seconds in a straight line. Find तो बच्चे आज हम यहाँ ही रखते हैं, फिर मिलेंगे अगले सेशन में। ये प्रॉब्लम हमने आपके लिए छोड़ दिया, कोशिश कीजिए, अगर ये हो सकता है तो करके मुझे बताइए, नहीं तो फिर हम कल इसको दोबारा तुम्हारे लिए करेंगे। ओके, बाय।